Welcome back, guys. In the previous video I solved some examples on limit, and I talked about a technique called dividing out technique, and I promised to solve 2 more examples. So in this video I'm going to be solving the 2 examples. The first example is limit nx tends to 3 minus x divided by x squared minus 9. So this is the function that is given to us. You just have to follow the same strategy by plugging in 3 into our function, replacing x with 3 in this case. So let's plug in 3. We have 3 minus 3 divided by 3 squared minus 9. 3 minus 3 is 0, and x squared, 3 squared is 9. 9 minus 9 is 0. So we can see that our answer is still an indeterminate form. Now we can't leave it like this. We have to look for where x is having power. In the numerator, x is not having any power, but in the denominator, x is having power. So we have to expand this function here. We now have limit when x tends to 3 minus x divided by x minus 3 x plus 3. So this is what we have. In the previous video I checked to be sure that this function is actually, this is the expansion of this function, sorry. So let's check again. We have x minus 3 x plus 3. X multiplied by x is x squared. X times positive 3, we have positive 3x. Minus 3 multiplied by x, minus 3x. Negative 3 times positive 3 is negative 9. So plus 3x and minus 3x will cancel. Find out that our final answer will be x squared minus 9. As you can see, we have the same thing here. So that means this expansion is correct for this function. Now we can now proceed to the next step. Our limit is limit x tends to 3 minus x minus 3 x plus 3. So this is what we have after expanding this our function in the denominator. Now we are finding we have to look for a way of eliminating this our function in the denominator. We have 3 minus x minus 3 plus 3. Now I can continue solving this by flipping this x. If you flip this x to the other side, we have minus x minus 3 divided by x minus 3 x plus 3. I flipped this x here. So we can now cancel this one, can now cancel this. So we now have, oh sorry, I didn't put limit x tends to 3. Yeah, so we now have limit when x tends to 3 minus 1 divided by x plus 3. This goes here 1. This one will cancel this, so we have 1 here. We have 1 here, so that's why I have this 1 here. And we have negative here. We have negative 1 divided by x plus 3. So we can now replace our x with 3. We have minus 1 divided by minus 3 plus 3. So our final answer will now be minus 1/6. So that's our answer. So the last example I have here with me is, which is 4. We have limit x tends to 0, 3x divided by x squared plus 2x. This is another example. So we have to plug in our 0 again and see if our answer will be in determinate form or indeterminate form. By plugging in 0, we have 3, replace x with 0, divided by 0 squared plus this. So 3 times 0 is 0, and this one will also give us 0. So this form is indeterminate. Now we can now check again and see where our x has power. Our x is not having any power here, but it's having power here. So we can expand this function. By expanding this, we have limit x tends to 0, 3x divided by x plus 2. So I've expanded this. Let's check again if to see if we are to be sure if our expansion is correct or not. We have x plus 2, x multiplied by x squared, x multiplied by positive 2 will give us plus 2x. So as you can see, our expansion is correct. So we can now proceed. So what we have so far is limit x tends to 0, 3x, x plus 2. Now, this x will cancel with this x. What do we have left? We have limit x tends to 0, 3 divided by x plus 2. So we can now plug in 0 into our function now. We have 3. If we plug in 0 here, we have 3 divided by 0 plus 2, which will be equal to 3/2. So that's our final answer. As you can see, this technique is straightforward, but I think the problem students always have with this is how to expand the function here. How to expand the function, but you just have to look for a function that will really fit, or that really fit with this thing that is given. Like here now, I know that to find x squared, to find x squared, I need to have 2x. That's why I put x and also x. I know that I will surely have 2x because I have x squared there. Now, what you have to do is you have to look for two values that you that if you multiply those two values together, you will obtain this answer here, which is -9. So if we try, let's try. So for us to be able to get any negative value, it should be negative something multiplied by positive something. So you now start guessing, like here now, or it can be positive something multiplied by negative something, like a value, sorry. So if you put negative, if you use -2, this something will be 2. -2 multiplied by +2, you get -4. Now I try using -3 and +3, or you can also use +3 and -3. It's still the same thing. So that's how I obtained this here. Then you just have to check if the expansion is correct with the function we are trying to expand, and if you notice that it is correct, then you can proceed with your solution. So guys, I think that's all for this video. In the next video, I'll be talking about another topic entirely, which is another technique, which is rationalizing technique, and that one is a long process, but I'm sure after the video you will have full understanding on how it works. Thank you guys for watching.